All right, Honors Algebra 2 and Algebra 2. Here's Mr. Yak with the pretty okay videos you've known to come to love. On page 6, section 2, section 2.6, page 6 in your 2-5-2-8 game plan. Here we're going to look at number 2 and 3 on this page. All right, so if you've missed some time, if you missed some questions, here's number 2. Here's how we're going to handle it again. You have y equals this piecewise function given to you, 3 pieces here. First one is y equals 6. So as long as I can plug in an appropriate x value, y is going to be 6, no questions asked. X is less than or equal to -1. Even if it just said less than -1, I would use -1 and then a number less than -1. How about -2? You have equality less than or equal to, so you close that circle at -1, 6. Then our next one is y equals 2x, and I don't even have to ask. I'm going to use my lower bound, -1, upper bound of 4. Yes, I know that technically x can't be -1, nor can it be 4, so I'm going to use an open circle. They can get very close. X can get very close to -1 and 4, but it can't be exactly -1 or 4. Now y is double that. All right, we'll look at what that means graphically in a second. Then finally you have y is 4 minus x. X is 4 or more, 0, -1. You have equality. Close that circle. All right, -1, 6. -1, 6 is our first points. 1, 2, 3, 4, 5, 6. Close circle, -2, 6, close circle, and I'm going to shade to the left. -1, -2 is an open circle. 4, 8 is an open circle. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 4, 0. 5, -1. All right, it's 4 zeros, closed circle. Again, you only have to ask yourself, open or closed circle at these transition points of -1 and 4. Everything else has to be a closed circle. Okay, there's only going to be 2 open circles, maybe only 1 in these graphs. We'll see. We might see one where it's only 1. All right, so let's do number 3 here. Again, these do take a little bit of time. Number 3, again, you have y equals 1, 2, 3. Y equals 2x. I did make a boo-boo on this one. You really can't graph it. So x is less than or equal to -6. So I use -6 no matter what, even if it just is less than. And I double it, -12, -14. That's going to be an issue. We'll see in a second when we try to graph it. Here you go. Closed circle at -6. 2 is y equals 5. -6 and 2, and y is going to be 5 no matter what. Open circle at -6, closed circle at +2. The next one is y equals 3x. Now I know it says x has to be bigger than 2. I'm still going to use 2 there. I'm just going to put an open circle at it, and then I'm going to use 3 and say -3x. All right, so I've got my points, and whether or not I'm going to have an open or closed circle. Again, only at those transition points do I have to worry about open or closed circle. So as we can see, there's going to be an issue here with -6, -12, 1, 2, 3, 4, 5, 6. -6, -12 is like right there. And then, -7, -14 would be like right there. So that is my mistake. Y equals 5, so I have -6, 5, and 2, 5. So -6, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, open circle. Whereas 2, 5 gets the closed circle, you have that barbell there. And then 2, -6, 1, 2, 3, 4, 5, 6. And then 3, -9. going down like that. Okay? So those are two piecewise functions there. Piecewise functions are the hardest ones. You shall see. Then page 7's on your own, and oh man, more piecewise. Okay. Let's do number 8 on page 8. Let's look at number 2 real quick. This will be a sizable video, I would imagine. Number 2, y is 2x. All right, x less than -3, I'm going to use -3, then I'm going to use -4. So -6, -8, my y value, open circle. Then I have y equals 1. Y equals 1, -3 and 5. Close circle with -3. Open circle at x equals 5. Y is 1. And then I have y is x minus 2. X is 5 or more, so how about 5 and 6? That would be 3 and 4, close circle at x equals 5 there, because you have equality greater than or equal to 5. All right, so I'm going to go to platinum, -3, -6, 1, 2, 3, 1, 2, 3, 4, 5, 6, and that is an open circle. Then I have 4, -4, -8. Then I have -3, 1. Then I have 5, 1, 1, 2, 3, 4, 5. Then I have 5, 3. Then I have 6, 4. All right, so then on number 3 here, let's talk about number 3 again. You're going to have 2 of these in your next quiz. I would imagine 1 on the Chapter 2 test. All right, so this first one is y is x plus 4. And the middle one is y is 2x minus 3. And then the third one is y equals 5. I make an x, y table. That's t table for both. On this last one, I know that y is going to be 5 twice. So on this first one, x is less than or equal to -2, so it can be -2 and -3, not -1. It's going to be a closed circle at -2 too, because you have equality. Then when x is between -2 and 6, open circle at -2, closed circle at 6. Double it, subtract 3. That's your y value, -7 and 9. Then the x values I'm going to use on this third one are going to be 6, open circle, and 7. Okay, so I got -2, 2. Gonna plot it up here, -2, 2. -3, 1, all right. -2, -7, going south here, 1, 2, 3, 4, 5, 6, 7. And then 6, 9, 1, 2, 3, 4, 5, 6. I think that's where 9 is. 1, 2, 3, 4, 5, 6, 7, 8, 9. Great. -3 is the y-intercept. You can see that. And then y equals 5, so I have 6, 5. Open circle, 1, 2, 3, 4, 5. Then 7, 5, 8, 5, 9, 5, and so forth. Okay, it's an odd-looking one, but that is my piecewise function there on page 8. Let's go to page 9. Page 9. Now I'm graphing absolute value. Equations, emphasis on equations. So again, number 1, I gave you the generic absolute value graph. To find the vertex, it's all about what do I plug in for x to get back to 0? Because in my generic one, my vertex was 0, 0. So I'm trying to find what do I need to plug in for x to get back to that 0, 0. And it would be a -2. So remember, this is your vertex, -2, 0. You're not adding or subtracting any number. When I plug -2 in for x, I get y is 0. Okay? For symmetry, I go 1 to the left, 1 to the right, 2 to the left, 2 to the right. Now, we know what the slope is. It's 1. Again, coming the other way, it's -1. So that's one way to handle it. Again, you can always just plug these numbers in, -1 and 0 in for x. get the absolute value of 1, which is 1. I get the absolute value of 2, which is 2. So when I plug negative 1 in for x, I get 1 for y. Same thing as if I plug negative 3 in for x, I get 1 for y. If I plug 0 in for x, I get 2 for y. Negative 4 in for x, I get 2 for y. All right, negative 4, 2. 1, 2, 3, 4. And it makes a v. Again, negative absolute value. Negative absolute value something will make the TP. This will make the v. Let's go over to page 10. I'm writing down that I will do a lot of those. Maybe all of them on 10 here. So what I'm going to do is I'm going to set what's inside equal to 0. X plus 4 is 0, so negative 4. Now I know what the slope is, it's 2. The y-coordinate in the vertex is not 2, it's 0. Again, when I plug negative 4 in, I get 0 times 2, which is still 0. I'm not adding or subtracting anything. 1 to the left, 1 to the right, 2 to the left, and 2 to the right. I'm going to take that, so I know the slope's 2. So I know that I'm going to go up 2, another 2, another 2. And you know that because it's 2 times x. It's looking right there at you. Again, if you don't like that, I can plug negative 3 in for x. I get 2 times the absolute value of 1, which is 2. I can plug in negative 2 in for x, and I get 4. Negative 6, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Negative 5, 2. Negative 4 is 0. And I have symmetry. Makes that's v. Now 5. Negative 3 times the absolute value is something I know. This has got to make a TP. I can use that to help myself out a bit. All right, so I'm going to set what's inside the absolute value equal to 0. I get x equals 5. Again, I'm not adding or subtracting anything, so my vertex is still 0. My y-coordinate in the vertex is still 0. That will finally change to number 6. When I plug 5 in, I get 0. I get 0 times negative 3, which is 0. Now my slope's negative 3. 1 to the right, 1 to the left, so I know I will go down 3. Another to the right, another to the left. I will go down 3 in both directions again. So that is for some of you. If you're in honors algebra 2, I would hope we could all notice that. In algebra 2, I'd hope a few of us could know that as well. Again, I can always plug in my numbers. I'm going to plug 6 in for x, negative 3. I'm going to plug 7 in for x, negative 6. All right. Again, symmetry. I know that it's going to be 4, negative 3, and 3, negative 6. 3, negative 6. 1, 2, 3, 4, 5, 6. 4, negative 3, 5, 0. Boom, and boom. Makes a lovely little Christmas tree. Tree, TP, whatever you want. And let's do number 6 on this page together. All right. We can see that the slope is 2. This time I do have a y-coordinate on my vertex, so that is not 0. X-coordinate of the vertex is a negative 7. Make sure to get that right. Y-coordinate of my vertex is a negative 3. One left, one to the right, 2 left, and 2 to the right. I'm going to plug a negative. Again, I know the slope's 2, so up 2, up 2, up 2, another up 2. So on a quiz or test, you can definitely do that on your game plan. Let's write it out. I'm sorry, it's a positive 2. It's like, that's not going to work. It's 2 times 3, which is a negative 1. Check. All right, and then I'll plug 1 in for, negative 5 in for x. 4 minus 3 is 1. Check. All right. Let's plot them points. Negative 9, 1. Negative 8, negative 1. Negative 7, negative 3. Boom and a boom. And that's page 10. Let's go to page 11. I wrote down that I was going to do that one, but I think we get the point. I mean, 10's got a lot of good ones there. On page 12, I'm going to do number 2 with you. Okay, we have a linear inequality. So these should be a relative piece of cake. This is the y-intercept. The y-intercept is 5. 1, 2, 3, 4, 5. Slope is negative 1/2, down 1 over 2. 2 points to terminal line. All you gotta do is make 2 points. You can keep going down 1 over 2 as much as you want. I have less than or equal to. That is a solid line. Less than or equal to means I'm going to shade below. You can trust it in slope-intercept form. I make a solid line of which I shade below. Okay. Let's keep going. Let's do number 6. Negative 2 is the y-intercept. Negative 2 is the y-intercept. My slope is 3/4, so up 3. 1, 2, 3, 4. Greater than or equal to, that is a solid line. Solid line. And greater than or equal to means I am going to shade above. When it is in slope-intercept form, you can trust that inequality sign. Whereas, we're going to take a look on the next page, number 8. Next page, number 8. All right, so this is written in pretty much standard form. I know we got a greater than, but think of it as standard form. So 4x is equal to 12. Cover that method. Your x-intercept's 3. Negative 3y is equal to 12. Y is a negative 4. Your y-intercept is negative 4. All right, so x is 3. Your x-intercept, 1, 2, 3, down 4, 1, 2, 3, 4. Greater than means a dotted line. Greater than means a dotted line. All right, greater than. Ooh, I almost got to where I wanted to shade above. It does say greater than, but let's be careful. Let's test 0, 0. All right, I'm going to plug 0 in for x, 0 in for y. I get 0 is greater than 12. Into your initial inequality, plug 0 in here, 0 in there. 0 minus 0 is 0. 0 greater than 12, man, that is false. So that's false. 0, 0 is above the line. Anything above the line is false. So I shade below. So you need to be careful if something is written in standard form, especially if y is negative. Because if you move that to slope-intercept form, you divide by negative. You have to flip the sign. All right, let's take a look at number 9. Just going to move that over. Y is less than negative 3x minus 2. The y-intercept is a negative 2. The slope is a negative 3 over 1. Down 1, 2, 3, down 3 over 1. You have a dotted line. You have a dotted line. And you're going to shade below. Dotted line and you shade below. All right, that is 14, and we are making some good progress. Gonna skip page. 15. And honestly, we're going to end on 16. All right, so we are going to end on page 16. That is going to be it. We've done a lot of problems. We will have an example of each, except for I'll go to the very end, but that is going to be good. Page 4, or number 4 on page 16. Absolute value inequality. So what I do is I find the vertex. 1, 5. Y coordinate of the vertex is 5. One to the left, one to the right for symmetry. Another to the left, another to the right. I know the slope's 1, so I'm going to go up 1 in each direction. Again, I can plug 2 in for x. And I get absolute value 1, which is 1 plus 5, 6 there, 6 there. I'm going to plug 3 in for x. I get the absolute value of 2, which is 2 plus 5, 7. Negative 1, 7, 0, 6. 1, 2, 3, 4, 5, 6, 7, 0, 6. 1, 5, boom, and boom, makes that V. Take a look at the inequality sign. You have less than or equal to, so this is going to be solid, a solid line. And less than or equal to means you are not going to shade above the lines, or inside that V, you're going to shade below the lines outside. All right, so these are probably the second hardest graphs you shall see. And number 5. Set what is inside the absolute value equal to 0. X is a negative 1. 0. Plus or minus nothing. 1 to the left, 1 to the right. 2 to the left, 2 to the right. The slope is 3, so if you're in honors algebra 2, we should feel comfortable doing that, and we're ready to go. These can be quick if you start noticing some things. If not, you plug 0 in for x, and look, you get 3. You plug 1 in for x, and you get 6. Time to plot. Negative 3, 6. Negative 2, 3. Negative 1, 0. Greater than or equal to, so you have a solid solid lines. If I said just solid line before, it's wrong. Solid lines for these. Greater than or equal to means you're going to shade above them or in between. Those two curves above the lines. And lastly here, before one of the last pages, number 6. Y less than or equal to 2 times the absolute value of x plus 3. Set this equal to 0. That's it, x is 0, so the x-coordinate of your vertex is 0. The y-coordinate of your vertex is staring at you. It's 3. That 2 is the slope. So 5, 5, negative 2, 7, 7. Again, just plug 1 in. Five, 7. Negative 2, 7 is where we're going to plot first. 1, 2, 1, 2, 3, 4, 5, 6, 7. Negative 5, 1, 1, 2, negative 1, 5, 3, 4, 5, 0, 3, a boom, and a boom, less than or equal to solid lines. Because of equality, I'm going to shade under the curve because it's less than or equal to. And then, folks, to finish this, we are going to go to page 20, do number 1, and this, holy cow, long video will be over. No more piecewise functions, except for evaluating them. Okay, so your honors algebra 2, your quiz will end like this. Algebra 2, you'll have one of these, I don't know, either at the end or in the middle. Okay, this is a piecewise function. This would be a fun one to graph in 2 different pieces. So when x is less than -2, x is greater than or equal to -2. So first off, f of -5 means when is x allowed to be -5? -5 is less than -2, so this is equation 1. That means I take -5, I plug it into equation 1 and equation 1 only. All right, and then again, I gotta know how to do this arithmetic. I get 78. When is x allowed to be -3? In equation 1, -3 is less than -2. 2 times 9 plus 15 plus 3 is 36. And then I get when is x allowed to be -2? Take a look here. Greater than or equal to -2. That is the second equation. X is allowed to be -2 in the second equation only. So it's going to be 8 minus 5 times -2, which is 8 plus 10, 15. Then when is x allowed to be 4? 4 is definitely greater than or equal to -2 in the second equation as well. 8 minus 5 times 4 is 8 minus 20, which is -10. And this video is now done. A lot of answers in here. If you're gone, this is how we do certain problems. You get a problem from every section. This is Yak Math Videos, signing out.